Hello, everybody. I am Jadi Zahrawi from NCS College of Engineering in Morocco, National School of for Computer Science and System Analysis, and also the mentor and the past chair at the IEEE NCS Student Branch. This year, the IEEE NCS Student Branch organized the Arab IoT and AI Challenge, where high school students, startups, and graduate students will participate with their innovative ideas in the fields of artificial intelligence, Internet of Things, and all the related fields. As we know, today we will organize the first webinar on the framework with this challenge. Our counselor, Professor Mohammed Saidi, will not be able to be present with us today, so he gave us an opening word that we will let you to move to listen in a few minutes. Share screen.
Good morning, ladies and gentlemen. It's my real pleasure and honor to welcome you to this first webinar in the framework of the webinars we have scheduled in framework of the Arab IoT and AI challenge. More specifically in the edition organized in Morocco. And I have the honor and the pleasure to welcome to this first webinar my friend and colleague, NARANG Kishor. Kishor is a technology consultant, mentor, and design architect in electrical, electronics, and ICT with over 40 years of professional experience in education, research, design, and consulting. Over 30 years of hardcore research and design development experience in solutions, systems, products, hardware, software, and firmware, embedded software in fields of industrial, power, IT, telecom, medical, energy, and environment, and over 10 years of consultancy experience to different segments of business and industry. Has over 200 research and design mentees in electronics, ICT, and STI ecosystem. Professionally, he is an electronics design engineer practicing design and development of a wide spectrum of products, systems, and solutions, and as independent design house. NARNIX since 1981. For the last 10 years, he was deeply involved in standardization in the electrical, electronics, communications, and information technologies domain, with focus on identifying gaps in standards to address interoperable systems and solutions deployment and bring harmonization by defining standardized interfaces to ensure end-to-end interoperability. Currently leading the standardization activities as the chairman of Smart Infrastructure Sectional Committee, LITD 28 in BIS, the Indian National Standards Body, Vice Chair Strategy and Convener, Reference Architecture, WG, in IEC System Committee on Smart Cities, Project Leader, IEC 63, 188, 81 Smart Cities Reference Architecture, Methodology, Project Leader, and so on and so forth. So you can check his bio, which is provided in the link in the IEEE NCS Student Branch website in relation with this event. So I'm really very happy to have NARANG as a speaker in this event, and I think that this is a wonderful opportunity to network with, Indian researchers technologists and technology leaders, and especially for student branches from IEEE, that would certainly get an insight from what's going on in India in terms of technology and the different aspects related to IoT, artificial intelligence, and different applications in different areas. Just also give me a few, I would say a few seconds or even a couple of minutes to talk about the IEEE NCS student branch, which is one of the very active student branches in Moroccan universities and engineering schools, that is also part of IEEE Morocco section, which is organizing different events, activities, and initiatives. And one of the initiatives we're also working on right now is to establish a Smart Cities Hackathon to be organized at the international level within IEEE with the help of the IEEE IoT Smart Cities Alliance initiative. And I look forward also to develop some kind of collaboration and cooperation with technologies and industries and student branches even in India and beyond. So without much ado, I would like also to reiterate my most sincere thanks and gratitude to my friend NARANG for this wonderful talk he's providing, which is focusing on the future of life disruptive technologies imperatives, which is very, I would say, thoughtful and insightful talk that would certainly help our students get an insight of what's going on in different areas, technological areas, emerging technology areas. Well, once again, thank you so much, NARANG, and wish all the participants a very fruitful and insightful session. Thank you.
Thank you, Professor Dr. Mohammed Saidi. As we know, our counselor is very active in the IEEE activities. He is the founder of the IEEE Morocco section and also the IEEE IoT Smart Cities Summit co-chair. So we will move now to the keynote speak with our guest, Mr. NARANG Kishor. He will give us a keynote speak about the future of life disruptive technologies imperative. So I will give the talk to Mr. Kishor. Hello.
Yeah. Hello and welcome. It's really a pleasure to be amongst you. I've been talking at the Indian platform and global platforms, but never had an opportunity to interact with this regional group that Professor Mohammed has given me the opportunity today. And I really look forward to, sharing my thoughts with you people. And I'll be happy to, mentor, guide, interact with you one-to-one. You can connect with me through LinkedIn, through Facebook. You can get my coordinates, write a mail to me. Because for me, design and training, they are two sides of the same coin. Okay, and mentoring the young breed has been my passion for last 4 decades. Because in design, it's not simply important to become you yourself as a good design engineer, but to groom the budding engineers, and which has been my real passion for from very beginning. So that's why I have a very good network of good students, mentees who have really done me proud. And whatever my credentials are there, it is basically because the way they have performed in the industry when they after they left NARNIX, spending first few years getting groomed and getting trained and learning how to design different kind of products, system solutions. So I think without wasting much time, I'll like to, share my screen and let's go with the thing application. Okay. Okay. Can you see my screen? Is my screen visible? Yeah. Okay. Yeah. So the topic today is quite relevant, okay, and that is future of life, the disruptive technologies imperatives. So a crisis as life-altering as the coronavirus pandemic naturally inspires speculation about how it will change everything. These are days definitely to be silent, keep quiet, and introspect. Let us understand ourselves. These days, we got to learn that human desire to overpower, avariciousness to dominate people and land, desire to rule the universe comes to nothing in front of a nanovirus which stealthily can impact the whole of humanity. Starting from a wet market in China's Wuhan or maybe a nearby lab, the novel coronavirus has reached the remotest corners of the world. The impact it has had and continues to have on each and every aspect of our life is in fact beyond words. We may not yet know how the story ends because even after a year, we do not see any end to this. Okay, we have already lost more than 1.3 million human, and more than 35 million people have got infected. And so that is why the challenge is we may not really know how will this story end, but we already know for sure that this pandemic has brought the greatest reversal of our times, turning the world along with its wisdom on its head. This is a free chance to unlearn and learn. Let us not blow it. And coming to technologies, I think it has been observed that the technologies developed by human beings in last two, three centuries have had a major impact on the Earth's climate and our nature's equilibrium. Some believe that we have reached a point of no return. This can have a huge impact on life on Earth, especially on the human species. However, while technology has been responsible for most of it, technology also seems to have solutions for it. So, and we all have seen what kind of disruption we are going through in every aspect of our life. So, but let's see what disruption is all about. And everybody is saying disruption is the new normal. Okay, now what is the new normal? What is disruption all about? If you really go back to see what is disruption all about, Peacemaker, the ironically named advanced nuclear missile that emerged from US arsenal during the Cold War, with the ability to carry 10 independent payloads, each of which was 20 times more powerful than the first nuke dropped on Hiroshima, changed the future of warfare forever. This incident indeed created the worst carnage known to mankind and made every weapon used until then obsolete. It changed the fundamental principles of warfare and is till date deterring humanity from plunging headfirst into another world war. Likewise, this pandemic is going to have profound and everlasting impact on how the human race evolves in the post-COVID-19 era. Today, management of large organizations, startups, or governments alike face the same challenge that Roosevelt did during the Cold War. Will your organization today approve a radical idea, allocate funds, and be the early adopter amid the crisis? Or will it stay stuck in the labyrinth of your legacy and perish? The global business dynamics is going to witness sea change in the coming times. And as Professor Clayton M. Christian, the scholar who actually introduced the disruptive innovation theory, says, disruption is a process, not an event. And innovation can only be disruptive relative to something else. So the question is, are you going to be an innovator, an early adopter, or a laggard? So what is the technology? We always talk about technology, but for any individual, whether for you young guys or for someone like me, technology is actually anything that was not around when you were born. Because what was already around when we were born, we do not consider them as a real technology. We take it for granted. Okay, and then there are some most profound technologies. Okay, and what are those? The most profound technologies are those that disappear. Now, how do technologies disappear? They weave themselves into the fabric of everyday life until they are indistinguishable from it. And then coming to the disruptive technologies, that is the topic of the day. Disruptive technology is actually the bearer of tremendous opportunity, but equally a harbinger of obsolescence. Technology's impact on society and business is substantial, if not underestimated. Though product life cycles are accelerating, the underlying technologies unfold over many, many years. Within each trend, there are multiple enabling technologies, all at various stages of maturity and adoption. Like, for example, we talk about IoT today. It was there for last 3-4 decades. It was called M2M, or even before that, control, SCADA, all kind of automations, and then it became machine-to-machine communication. Now it is called IoT, and now it is being also considered, Internet of Everything, and all those new avatars and new terms and terminologies. Okay, and coming to artificial intelligence, if you really see, it's another thing. The current wave of progress and enthusiasm for AI began around 2010. While AI has been in the research zone for last 4 decades, driven by 3 factors that built upon each other: the availability of big data from many sources, dramatically improved machine learning approaches and algorithms, and capabilities of more powerful computers. So these were 3 factors which actually made AI such a great success and even a hype, I'll say today. Otherwise, before that, AI was there, but it was only in the research labs. It has not come to the mainstream the way it has come, overtaken each and every domain, paradigm, technologies. Everywhere AI is, you find everywhere AI being applied for any kind of product, system, solution. So AI plus. So this is a very interesting graphic which I like. A robot repairing itself. That is the kind of intelligence we are looking at, in a very near future. And there are so many other disruptive technologies, whether blockchain or IoT or, you can say hashcraft and smart manufacturing, Industry 4.0, you are talking cyber physical system. These are all different aspects. They are going to impact our life in the very, very near future. So understanding a little bit more about disruption. Disruption is everywhere and the future is really uncertain. No one knows what the world will look like even a decade from now. As we head into future, we are surrounded by disruptive innovation, whether it is artificial intelligence, driverless cars, space exploration, or quantum computing. It can be hard for even the most enthusiastic technophiles to stay up to date with all the rapid advances taking place and coming down the line. These innovations are changing the world as we know it. For example, how the combination of AI, IoT, and blockchain is creating both disruption and opportunity in the enterprise world, not just for consumer-facing businesses, but for all enterprises. Over the coming years, what will be the most important developments in disruptive technology? As we look to the years and decades ahead, tech disruption will be driven as much by the methods and systems as it is by the devices we associate normally with tech disruption. There are several developments that have and will continue to shape business strategies, from automation to sustainability. Organizations are adapting to a whole new wave of consumer preferences. So let's do a little bit of crystal ball gazing and look into the future, what we can expect in a very near future. We could start seeing delivery drones finally start making deliveries very soon. A hyperloop could take us in between cities, and I think we heard last week they had the first successful trial run for a short distance. Machines could start thinking like humans as early as 2025. Space trips designed to send people to Mars. Prosthetics could get so advanced in the next 10 years that they could give people new skills. Clothes could give people superhuman skills in the next 10 years. Virtual reality could replace textbooks during the next decade. The smartphone will become obsolete by 2025. Why? Because all the smartphone features will get embedded into your environment, whether in some parts in your body or in your tables or in your chairs, in your bed, around in your ambience. It will be all the technology would be there. You may not need physical smartphone in next 5 years. We could live in a matrix like virtual world, and people could also become cyborg by 2045. Super tall buildings could function like mini cities in the next 20 years. We could rely entirely on renewable energy by the year 2050. So top disruptive tech trends to watch are, you can see cybersecurity, mixed reality, hyper automation, digital twins, not many. The interesting part is the pace of innovation is incredibly fast, with new things getting discovered daily, and literally daily. The future trends in technology are very diverse, very intertwined, and very promising. The cloud, as you know, will play an increasingly important role in the global accessibility of services and data, while the long-awaited availability of super broadband 5G networks will open a new chapter in the history of IT and make the dreams of today a reality of tomorrow. Top disruptive, some other the things are the pace of advancements in technologies is increasing at an unprecedented rate. The rapid change is largely fueled by democratization of innovation, as cutting-edge technologies like cloud computing is providing modern companies access to new disruptive technologies, irrespective of where you are located and where the new technologies are on the cloud. They have a lot to offer to an organization in an effort to transform its traditional business processes, advancing efficiency and leading to competitive advantages at the same time. Since the world now stands on the fourth industrial revolution, disruptive technology is also evolving faster than ever, and it has become fundamental to business growth, where companies need to implement this strategically. You must have witnessed that in COVID times, digitalization and digital transformation of all the organization, business, industrial, and any other kind of organization has really taken a front seat, and everybody has taken it as the top priority level to go digital, so that they can maintain their operational efficiencies even through remote or with a less you can say manpower and less resources. So these are the three main mega trends which we can look at: AI, artificial intelligence everywhere, but then there are those sub trends within the mega trend: deep learning, deep reinforced learning, artificial general intelligence, autonomous vehicles, cognitive computing, and all that you have. Then transparency, immersive experience. Then digital platforms, whether 5G, digital twin, edge computing, blockchain, okay, neuromorphic hardware, quantum computing, okay. So, and there are so many other disruptive technology trends that are being discussed. They are being worked about, and only time will tell who really wins, and there will be some losers which will die out. But these are some of the real disruptive technology trends you can look at and see what excites you, what really involves you, and where you can really do some interesting research, design, or whatever kind of projects you want to do. Then we have a main focus of today's innovators also on edge computing, human augmentation, hyper automation, democratization of technology, which I just mentioned, autonomous things, Internet of robotic things. We are still recently till now we have been talking Internet of Things, and the thing now we are looking at networks of robots, which will work in a very seamless, harmonized manner to give you over system level, plant level, building level, complete organization level automation. But you see that this pandemic has catapulted two diametrically opposite paradigms to the focus of mankind: digitalization, as we already just discussed, and sustainability. Why? Because we saw that in these times, during when all the countries were locked down, our nature, our the pollution, air pollution level, the carbon, the thing, greenhouse gas emissions, they really came drastically low, and nature started recuperating. We started seeing sky blue skies, otherwise which used to be polluted and dusted and grayish always, and clouded with whatever smog or fog or dust. So all this has covered. That means, what does it show? That we need to be very, very cognizant of what we do in our endeavor of industrialization or being overzealous about technology. So sustainability, whether it is about circular economy, whether it is about biomimicry, or any other way to reduce your carbon footprint and make your planet more sustainable, more livable for the future generation, we need to keep in mind, even when we are following all our new technology adventures, projects, digitalization, and all that. So the next digital revolutions, we all know: IoT, 5G, big data, artificial intelligence, and then quantum computing and others. The thing are there. So Coming to IoT, because that is, I think I've been told that is one of the area of interest for you all. So what is IoT? IoT, a concept that originally sounded like something out of a science fiction movie. The Internet of Things is in fact a reality, and one that is bound to become even more widespread. From being considered as one of the most disruptive technologies in early years of last decade to coming on the verge of becoming one of the most profound technologies by weaving itself into the fabric of everyday life until it becomes indissociable for it. Because IoT we are looking at everywhere, in every aspect of our day-to-day life. We are finding that IoT has some use case, some application, some kind of a help it can do to improve our operational efficiency, help our work and life, so social life, personal life, business life, industrial life, and whatever, enterprise life, and whatever you may say. So, but what it is all about. So, to sum it up in a very simple language, Internet of Things is all about heterogeneous and aware devices interacting with each other to simplify people's life in some way or the other. Yes, even the smart toothbrush, smart shoes, and all the smart hats, they also can be considered. They will be theoretically, technically, yes, they would be IoT, this thing, but those are not the kind of IoT applications that we are actually looking at. What we are looking at is some kind of product, system, solution, which actually should help the people's life, the mankind, one way or the other. Whether it is our technological problem, or even like in COVID-19 time, we have seen how IoT has come to the rescue of mankind by providing so much of remote monitoring, remote this thing, by tracking the patients, the infected people. That it is really amazing how this IoT paradigm has become really ubiquitous and pervasive. So what exactly it is all about? Key components of the IoT are sensing nodes, local embedded processing nodes, connectivity nodes, software to automate tasks and enable new classes of services, okay, remote embedded processing nodes, and last but not the least, full security across the signal path. These are some of the key components that we need to keep in mind whenever we are talking of any IoT-based product system solutions. And if you look at the ecosystem, IoT ecosystem and the value chain, I think it is perhaps the most diverse and complicated value chain of any industry or consortium that exists in the world. In fact, the gold rush to IoT is so pervasive that if you combine much of the value chain of most industry trade associations, standard bodies, the ecosystem partners of trade associations and standard bodies, and then add in the different technology providers feeding those industries, you get close to understanding the scope of the task. It's such a complex ecosystem. In this absolutely heterogeneous scenario, coming up with common harmonized standards is a real major hurdle. We need to see acceleration and maturing of common standards, more cross-sector collaboration, and creative approaches to business models to make IoT really proliferate in a true way. Hence, in spite of so much hype and even genuine potential, IoT paradigm has not proliferated in a true sense to its desired potential. Why? Another point that is a hurdle is bringing the Internet of Things to life requires a comprehensive system approach, inclusive of intelligent processing and sensing technologies, connectivity, software and services, along with a leading ecosystem of partners. If you think you as a small organization can give somebody a complete end-to-end solution of IoT, I think that's an absolutely misconception. Because there are so many aspects to IoT that you can, as a small organization, you will never be able to do it alone. So you need to work with a lot of other partners. Someone brings in the sensing node, someone brings in the processing node, someone brings in communication, someone builds in the cloud platform, someone brings in the apps, and someone does the services management or marketing and all those kind of things. So that as a wholesome, it becomes a very good package that you can offer to any client value for their money. So maturity stage of IoT component, if you really want to look at, to give IoT the required momentum, device management platforms, cloud computing, and big data science in the virtual world are already flourishing and well geared up to meet the expectations of designers. But the physical world needs to catch up. The wireless and networking technologies need to mature very fast. We need innovative approaches in deployment of large sensors and actuator networks. If you see wireless and networking technologies, there are so many technologies, so many communications that they're all heterogeneous. So every network ends up being a proprietary network, and the working, interworking, and interoperability becomes a real challenge. So what are the application business models? If you really want to have take a reality check of hypes, myths, contemporary practices, and imperatives in the shifting socio-techno scenario, most analysts project a 20% CAGR for IoT, and that's faster adoption rate than the growth of any economy. To some, that means that things are not broken. However, as I mentioned, the ground reality is a far cry from this rosy picture. All IoT companies are still struggling to get a foothold in the market. And to profit from IoT for different nations, different ecosystems, and different stakeholders is highly dependent on the macro dynamics in their respective environment. So do not expect what works or what is very acceptable or super hit in US or will also be super hit in your region. So you will need to study your own regional, your own national macro dynamics to see what kind of products, systems, solutions, services will be really, you can say, the killer kind of application, which will find more potential. A comprehensive environment scan of macro dynamics within one's techno-socio-economic environment can help understand the impact on any IoT organization's business revenues and provide actionable insights to address the challenges and develop a long-term strategy and roadmap to evolve and mature into a sustainable IoT organization. See, because you must have already witnessed, there are a lot of IoT companies keep on coming up, but then again, they die out after a couple of years. Why? Because this very reason. They just try to, emulate some successful models somewhere in the world. That does not work. You need to understand your local dynamics and then develop your own strategy and roadmap and vision accordingly. So IoT use cases, there are plenty of them. I can't even count them if I start counting. But then how do these come? So there are so many technologies. They are all in support of business. As the technologies mature, you see, from 2G, 3G, the different kind of business applications start coming up. Okay, this is simply there. And then as, like enhanced mobile broadband, current scenarios, we have screens everywhere. But on the road to 5G, we have already started getting 4K video. When we have 5G in place, you will see that 4K, 8K immersive experience, AR, VR is kind of like a common thing. Okay, like automotive, you will have only autonomous control once you have a 5G well entrenched in the place. So that brings us to 5G, a very interesting technology. So and as they say, 5G is not just an evolutionary upgrade of the previous generation of cellular network, but it is a revolutionary technology and vision that will eliminate the bounds of access, bandwidth, performance, and latency limitation on connectivity worldwide. 5G technologies bring in a universal connectivity angle that has not been present in the earlier generations of wireless technologies. With the potential for 5G networks to provide anytime, anywhere connectivity to anything, the number of applications or domains which can leverage this kind of connectivity will be quite large. 5G will be the connectivity fabric of new era of information technology that will transform every sector of the economy and society. 5G has the potential to enable fundamentally new applications, industries, and business models, and dramatically improve quality of life around the world via unprecedented use cases that require high data rate, instantaneous communication, low latency, and massive connectivity for new applications for mobile, e-health, autonomous vehicles, smart cities, smart homes, industrial IoT, just to name a few. So what are the enabling technologies and paradigms for 5G? Virtualization, IMS, SDN, orchestration, evolved packet core, machine learning and robotics-based closed-loop self-healing, network slicing on transport and core layers of the network, then ultra-high storage and compute, big data stacks with all the networks, customers, performance, and cloud source data. And these are some of the key attributes that the 5G paradigm brings on the table, which were not there earlier. So it is a distributed architecture rather than a constrained architecture that earlier, all telecom technologies were. They were like a unique dump pipe. Okay, but now we have gone totally distributed. There's a network slicing, then control and user plane separation, cloud RAN, virtual network functions on cloud native digital services. Microservices architecture is purely like softwareization of the telecom, if you really ask me. Continuously evolving software, DevOps, all the IT technologies are now being properly leveraged in the telecom to make the 5G a reality. And as we know, the wide range of requirements, the three broad use cases include enhanced mobile broadband, mission critical services, and massive IoT. And this is a very interesting future architecture that we are looking at. One network, diverse use cases. Okay, a common network platform with dynamic and secure network slices. So this is the kind of architecture that 5G is likely to bring in reality. And then there are some other kind of work initiatives. Now we are already started working on, Network 2030. These are some network architectures. This is ITUT work. This is a Network 2030 architecture framework. So you see, it's a very interesting amalgamation of multiple technologies from different domains that are helping to make the new architectures and new performance of the communication networks and infrastructure a reality. Then so this is another look at the Network 2030 architecture framework. Okay, the front hall, back hall, and again Network 2030, front hall on the other side, both the sides. In between there's the back hall. Okay, and then IEEE also has a future network initiative, and in that they are looking at some areas of consideration include the following: current state of technological development, mobility framework and pillars, evolution of current technology generation, interaction within the ecosystem and interaction among adjacent ecosystems, key enablers, for example, AI, position determination, cloud, and vision of 6G. So IEEE is also working on future networks quite a lot. So since you guys are involved in IEEE, take a look on the future network initiative. You will see what is that. Now, when we talk about IoT and 5G interplay, IoT may require very differentiated service level. IoT covers a large range of applications, and it can be machine to machine or consumer or healthcare or automotive. These applications will have varying degrees of requirements for connectivity as well as data transmission. While a healthcare device may collect continuous amount of data, a smart appliance may not have to be transmitting continuously. We can even consider within an automobile, for an example, various systems. All systems related to safety may need continuous monitoring and real-time feedback. However, an infotainment system may have different requirements. Environmental applications such as clean air, water monitoring system may have another set of requirements. All these applications will transfer varying degrees of data, some large, some small, and others will be a mix of these at various intervals versus real time. It may be important to understand that these requirements from a system perspective and offer differentiated class of services within a network that provides connectivity. So what is the transition from 4G to 5G? The major difference from a user point of view between 4G and 5G must be something other than faster speed. Increased peak bit rate, for example, higher number of simultaneously connected devices, higher system spectral efficiency, data volume per area unit, lower battery consumption, lower outage probability, better coverage, high bit rate in larger portions of the coverage area, lower latencies, higher number of supported devices, lower infrastructure deployment costs, higher versatility and scalability, higher reliability of communication. So you see, the expectations are going increasing and increasing as the technology moves from one generation to next. The expectation of the stakeholders are increasing by multiple bound. Basically, they are also in a way following the Moore's law. So 5G, what kind of role it is playing in the smart infrastructure, digital infrastructure? So to support the main vertical sectors, namely automotive, transportation, healthcare, energy, manufacturing, and media and entertainment, the most important 5G infrastructure performance requirements are a latency below 5 milliseconds, support for devices densities up to 100 devices per meter square, reliable coverage area. So a successful 5G deployment will integrate telecommunication technologies including mobile, fixed, optical, and satellite both Geo and Neo together to give you the whole bucket of services. And so it is not only one particular technology, but all the technologies. So the expectation from 5G, data rates of tens of megabytes per second should be supported for tens of thousands of users. 1 gigabit per second to be offered simultaneously to many workers on the same office floor. Several hundreds of thousands of simultaneous connections to be supported for massive sensor deployment. Spectral efficiency should be significantly enhanced compared to 4G. Coverage should be improved. Signal efficiency should be enhanced. Latency should be reduced significantly compared to LTE. So these are some further summary: a super efficient mobile network, a super fast mobile network, a converged fiber wireless network. So there will be no only wireless, it will be a convergence of fiber network and wireless networks. And now you'll say 5G is going to bring a lot of it. But if you really ask me, 5G is only the beginning. Actually, we are considering it like a car-benz automobile for the internet. Why? Because researchers and designers have started working already on 6G. So what we are talking about 6G? In 6G, we are talking about tactile internet, artificial intelligence to control objects remotely, comprehensively, seamlessly. Any use case you see, whether Industry 4.0, automated driving, guided surgery, Corona app, immersive app, this thing, everything. So different killer apps are loading our network. So how do we, meet this thing? So the issue is, you'll say what is going to be new in the 6G? Whatever we could not achieve properly in 5G, all those problems have been passed on to the 6G developers, researchers to do that. So these are some of the new challenges that 6G people are working on. Okay, and so if you see 1G to 6G journey, the 1G and 2G was traffic was basically dominated by voice. Okay, 3G and 4G were basically the traffic dominated by data. Okay, and then video also up to 5G. Then 5G and 6G is remote controlled tactile internet, traffic dominated by correlational data. We don't know what would be beyond 2030, and once we reach the thing, we will shift our goals and to look for something further which has not been achieved till now. So that brings me to something very interesting: digital transformation. Everybody is talking about digital transformation. Okay, but whether the society, the business, the infrastructure, the services, and all other aspects of civilization on the planet Earth are going through a paradigm shift in the wake of technological advancements, especially in the field of ICT. All the ecosystems, be it smart cities, smart grids, smart buildings, or smart factories, now find themselves making three classes of transformation. So digital transformation is all about these three classes of transformation: improvement of infrastructure to make it resilient and sustainable, addition of the digital layer, which is the essence of the smart paradigm, and business process transformation necessary to capitalize on the investment in smart technology. So what is the genesis of digital transformation? The way I would like to explain what digital transformation is, and the genesis is, in digital transformation, any paradigm, domain, or ecosystem, sustainability is the true destination, and resilience is the core characteristics of digital transformation. And smart is merely the accelerator where we put most focus. It is just an accelerator, and standards are the chromosomes of digital infrastructure of today, tomorrow, day after. Okay, now you'll say what digital transformation is all about. So digital transformation initially started with convergence of information technology and operational technology. Then came network technologies. Now we already have IoT technology. And now to top it all, we also have the artificial intelligence covering all domains: IT, OT, NT, IoT. Okay, so this is what digital transformation is all about. In any domain, artificial intelligence is into all spaces. Okay, whichever technology domain. And then if you look at the feature of a smart city, you see this, all these applications and features, they are all ICT and IoT opportunities in all the verticals, horizontal features, use cases, business cases, whatever you like to call them. Okay, so I think there's a whole lot of work for you guys to identify some particular favorite product, system, solution, vertical, horizontal within this smart city, smart infrastructure, digital infrastructure, whatever you like to call it, and put your focus, your energy, leverage your competence, your design knowledge, everything into this domain. Okay, so but what is the problem today? If you see like your smart city, current applications, they all live in silos. Everything is for every different utility has a different individual networks. Okay, so in a single city, we have 10, 15, 20 different ICT infrastructures and networks running. Does it really make sense? Today we are in the age of convergence. Okay, so what we did was we did a little back of envelope calculation a few years back for smart city and smart infrastructure for Indian business case, and what we realized that like India is only looking at 250 million smart electricity meters. Okay, these all smart meters will have at least one communication module in each, and at least 500,000 gateways or data center units. Similarly, if you look at, we are looking at 100 million plus smart street lights with 100 million communication modules. Okay, and 500,000 gateways again. Smart buildings are going to deploy more than 50 million smart sensors and at least 100K or 200K DCUs or gateways. Automobiles shall be using another 100, 200 million communication nodes for vehicle operation maintenance, V2V, V2I, and other telematic applications. Similarly, if you start adding all the use cases of the civic infrastructure alone, or the critical infrastructure of our Indian thing, okay, we are going to need minimum 5 to 10 billion communication modules to be integrated into smart sensors and controllers, and 10 to 15 million gateways that shall be needed to operate and maintain the nationwide critical or civic infrastructure that needs to be deployed to enable and empower the citizens to lead a sustainable, safe, and secure life. Imagine 10 billion. This number is more than what we have, mobile consumption in India. But what is the problem? This whole market is fragmented because first of all, every application is working in silo. Second, there are so many technologies, so many standards. Everything is fragmented. So the price for each and every product, system, solution is very expensive. The whole digital transformation journey of the urban infrastructure or the civic infrastructure is becoming so, you can say, unnecessarily expensive that we cannot really afford it. We are a financially constrained nation. So what we did was we looked at a very simple architecture, okay, for a smart city. And then what we realized that we can map this into, say, this is a 7 layers of information flow, whether you consider a case of IoT or a smart city or any particular use case. Okay, you'll see. So these are the like a OSI model equivalent of the 7 layers of information in the smart or digital infrastructure. On the left-hand side, you see how the data is moving and what is happening, nature of data ingested, nature of data analysis. And here, you see things, connectivity edge, global infrastructure, data ingestion, analysis, application processes. And what we realize when we map this to the 4 pillars of, the smart infrastructure, physical infrastructure, social infrastructure, economic and institutional infrastructure, what we realize is actually only the top 2 layers change or need to change as per the user requirement. All the lower 5 layers out of these 7 layers can actually remain same or should remain same. So what we did, we developed a very interesting new architecture, common unified architecture, where we merged the common layers, and this is the kind of architecture we came up with. And we did a complete smart city platform, key microservices, then data layer architecture we developed, last mile communication unified we developed. Okay, and so when we try to create the abstraction, everybody talks about hourglass architecture, because whether it is internet hourglass architecture or one M2M, end-to-end network view. But what we realize in our case, what we need is not a hourglass this thing, but what we need is a classic saucer champagne glass architecture. Why? Because the neck is now very long. We have multiple things that can be actually standardized, harmonized, and this thing. So what we see is at the bottom of this, if you see, we have sensors, controller, diverse, heterogeneous devices. But in the long stem, you see unified last mile communication, standardized gateways, common service layer in the gateways and the cloud, and smart city middleware. This can be completely common for all different use cases and all kind of application in a well-defined geographical territory. So this is the evolved, comprehensive, ICT architecture can actually be modeled as classic saucer champagne glass with a wide flat bottom base depicting the magnitude of a multitude of field devices and sensors. Okay, and this thing, it is a long stem of the champagne glass model instead of a short and narrow neck in the hourglass model that brings the comprehensive harmonization, standardization, and interoperability in the architecture, leading to optimization in operational efficiency and life cycle cost of ICT infrastructure in smart city. You will ask me, what does it bring? What value does it bring? So let me tell you. Once I merge my whole, 10, 15, 20 ICT infrastructures of a city into one single ICT common backbone, I bring down my CapEx, capital expenditure, my OpEx, my operational expenditure. Okay, I bring down my carbon footprint of the ICT infrastructure, and last but not the least, which is a real byproduct, is since this unified digital infrastructure of a city is well architected and completely under control. So it is very easy, relatively easy, I'll say, to make it secure and resilient. So cybersecurity issue, which is always at the back of mind of every ICT person, that also gets resolved by this kind of architectural approaches. So, and what we are looking for unified digital infrastructure, we need a comprehensive strategy. So it has so many aspects: governance and operation, trustworthiness, sustainability, and we, as in India, are working on all these aspects in a very structured, seamless manner. Just to share some thoughts on the Indian this thing. And then what we also realize in a city, data is everywhere. Am I right? And so, as Neelie Kroes, the European Union Commissioner responsible for digital agenda, said way back, if data is the oil of 21st century without pollution side effects, then big data that we are dealing with today is the crude oil. Am I right? Because it needs a lot of processing before it becomes usable. So, with widespread adoption of cloud, application data are leaving home. Digital transformation is all about data. Data's perilous journey. Let's take a look. What happens to data when it is moving from one place to another? Okay. See, here we got someone, two tabs. There are some thing, and so what does it bring to us? What does it show us? That we need to be very, very particular about securing our data and our network and our infrastructure. So the new challenge is securing the fifth dimension, the cyberspace. And this is a typical cyber threat landscape. The interesting part is the same technologies that we are trying to leverage for developing cybersecurity solutions, the same are also being leveraged by the hackers to hack our infrastructure and our ICT infrastructure and all that. So what do we need? We need a very comprehensive security philosophy, which is all about not extrinsic security, not a patch on, but an intrinsic security, security by design. Whenever you design an IoT product, system, solution, you have to, built-in security has to be built in. Okay, why? You just take a look at yourself. Today, how many IP addresses are on a person? Smartwatches, fitness devices, medical devices, smartphone, tablet. So, every person is carrying at least 5 to 10 IP addresses on you. And confidential information is passed between smartwatches and host phones. Medical and health devices store and transmit personal data. Device firmware and application updates are not necessarily secure. So you see the kind of threats we are facing. So what is the important part? The point is, chain is, you must understand that a chain is only as strong as its weakest link. It's a very old saying. And as a lot of people have started saying, now you don't need missiles or nuclear bombs to bring down an enemy nation. You just need a bunch of good hackers, and you can bring down even the most powerful nation on its knees merely by hacking and shutting down the critical infrastructure of the nation. And I think we already have seen some live examples in the last couple of years. So that brings me to some, when we talk about security, people talk about blockchain. People talk about artificial intelligence. Am I right? So artificial intelligence, coming to your favorite topic, and this is a buzzword. Artificial intelligence has become a way of life. Algorithm decide for every individual today. Okay, YouTube decides for us what video to watch next. Okay, Twitter decides whom to vote for, what to travel, etc. And all other social media application apps help us decide what to buy. So they are targeting individuals against target groups now. So what does it bring to us? Concerns about domestic and commercial artificial intelligence. AI is core to some of the most successful companies in history in terms of market capitalization, and along with information and communication technology, more generally has revolutionized the ease with which people from all over the world can create, access, and share knowledge. However, possible pitfalls of AI could have quite serious consequences. The questions in the mind of people are, will AI outcompete us? Will AI undermine societal stability? Will AI harm privacy, personal liberty, autonomy? Human memory has been outstripped by books for centuries. Mere intelligence is no more of a direct threat than mere strength. And let us see where we are heading. This is a very interesting video exemplifying the AI.
Mr. Narang, I'm very sorry, but I think we cannot hear the audio.
Oh,
This is the I think a problem in when you share the screen.
mm-hmm. What did you say? You can't hear the audio?
Yes,
Did you say something?
we can see the audio. We can see the slide, but the audio no.
Okay. Now I can't do anything. I think we tested ran, but I think the visual would be good enough. I'll explain.
Okay.
You can hear my voice?
Yes, we hear you. Yes.
Okay. Okay.
Thank you.
So let them see. Then I'll explain. So you see, this was just an illustration of what AI can do, what kind of negative impact also it can have. So it was just an example, okay, that how you can leverage it. And I think there are ample videos on this thing where you can see that through AI, you can identify people, through those cameras deployed in a city within a few minutes, if you have got his profile, you know. So there are so many ethical implications of this disruptive technology that we need to really look at. So, but the question is, a lot of people are worried about the singularity and all that. But I think there is some kind of a consolation also. Would digital brain have a mind, or the human brain and the digital computer share many traits? Simulating the mind in silicon may be impossible. Obvious parallels exist between the brain and digital computers, but to fulfill their responsibility to themselves and to others who might be misled by journalistic hyperbole, computing professionals should have a well-founded opinions about the extent of these parallels. The profession should refrain from applying humanistic names to its machinistic, endeavors, and it must be conscious always of the essential difference between people and computer. Why? Because see, the AI can give you intelligence, it can give you the thing, but it cannot give you wisdom. Wisdom is something which we as human acquire over a period of time, and the kind of data and the context that we have that builds over a period of time as we grow older. That kind of for AI, you need to train the machine with everything. Okay, and unless you train, so it has to fed some data. So how much data can you feed of your life experience, which we explore with consciously, subconsciously, unconsciously acquire during our lifetime? Will you be able to do that kind of a data feeding into our training into the machines? If you're able to do that, then they might reach that kind of a wisdom or the singularity, the paradigm that people talk about. So taking a look at the Asimov's law of robotics, law 1 is robot must never harm human being or through inaction allow human being to come to harm. Law 2, robots must follow instruction from human without violating rule number 1. Law 3, robots must protect themselves without violating the other rule. If you really look at it, law 2 and law 3 simultaneously cannot be complied by any robot. So that is a really conundrum. Either they'll follow 1, 2, or 3. So what we need ethics by design. So I think we have a lot of work in standards also in IEEE. There's a whole lot of work done on standardization for the thing. So we have a complete series of IEEE P7000, which are on the ethical design approaches and initiatives. So and it covers a lot of very interesting aspects. That how do we have ethically aligned designs? The work of the general principles and all these things on the thing. So let me share you something else about AI. This is my personal perception or understanding recently. We are talking about AI for sustainability also those days. So AI as a big hype is a reality today that scientists who worked on it for the last 4 decades never ever thought of or envisaged. It is actually terrifying, scary, and chilling, like the video I showed you. It is like riding the tiger. Shall we ever be able to get off safely or tame the tiger? To top it all, AI is now being leveraged to bring sustainability in different aspects. Forgetting the carbon footprint it adds to anything when you apply AI to any product, system, or solution. Why? Because AI needs a whole lot of compute power, processing power, and that itself has a very big carbon footprint and has an adverse impact on sustainability. So is it not a paradox? Okay, so we need to learn from our past mistakes, like past failures to consider environmental consequences early have been very costly. Semiconductor industry these are some of the examples where we did not, learn beforehand, and we impacted our environment. So there are some 4 snapshot of the Earth from the space. September 81, September 87, September 93, and September 97. Imagine the kind of pollution, the impact that it has been having. It has been growing and growing, and these are very dated ones. And imagine what it would be now if I have a picture of 2019 or 2020. So small adjustment early in the trajectory of any technology have very large consequences. We must introduce the environmental perspective early into the culture of emerging technologies. Advancements in multidisciplinary science, more complex science and ethical and preventive measurements. So the question is AI going to be the new plastic? And then another aspect, AI effect on human rights. Inherent tension between automated decisions making and procedural due process. Okay. First consideration of ethical design of AI is human rights. What is the ultimate goal of AI optimization? We need to frame human rights in terms of the substantive guarantees to food, shelter, etc. While the procedural norms tend to be deprecated, we need to define constraints of AI in design phase itself. So that's why I'm just giving you some kind of insight that whenever you design a product and try to leverage and deploy or apply AI, keep these few things in mind or study a little more about how to develop or design and ethically aligned designs. Okay. So what we need is not artificial intelligence. We need artificial intelligence. We need to keep our human sense ethos right there when we are applying artificial intelligence to any product, system solution, or problem solution design. Okay. Now, and that brings me to actually what an engineer is all about. So an engineer is an enabler of change. He or she is equipped with the ability to take society's grand vision or magnificent concept and literally make it work. In a world of increasing unpredictability, the role of engineer assumes a critical level of significance. The days of the ivory tower academia-bound engineers are over. The engineers of today and the future must acquire more than a nodding acquaintance with the concept of sustainability in all its aspects, social, environmental, and economic. So innovation, everybody is harping about innovation. Some say innovation is the key to rise in technology in the global arena. Am I right? But how do we innovate without the competence to innovate? That is the issue. So what we need, we need first to build up the competence before we focus on innovation or we start talking about innovation. The question is, how do we build? Whether we develop a product, some solution for cities, smart cities, or M2M to IoT or LTE or 5G, all these new technology, big data, AI, quantum, all these evolutions. Any particular domain you pick for your design, research, whatever. Wherever you want to build competence, what kind of skills do you need? As we said, IoT we need everywhere. What is the design engineer skill? We need to innovate. Every true IoT application or solution needs cross-domain expertise. Internet per se has been considered the forte and playing field of software professionals, but IoT brings new challenges in the way sensor fusion, communication technologies, and energy power management of the edge nodes. Unless a design engineer can design most optimized edge nodes and communication nodes, the solution shall not pass the acid test of reliable and sustained performance in the field deployment environment. So what are the kind of competencies needed for a design engineer to design and develop IoT product system solutions? You need to go back to basic electronic fundamentals, including but not limited to sensors, analog, power, RF, and various compliance issues in hardware design. In-depth understanding of the different communication technologies, protocols, and standards, particularly relevant to the domain and relevant to your applications. Understanding of security, privacy, socio-ethical implications of the solutions, services, and applications they are trying to develop. Embedded processing, data analytics, and other software skills are already considered as a must, so I will not emphasize on that. But within again, what are the gap areas? There's a major gap area in design skills of design engineers today globally. It's not specific to any country. Hardcore and comprehensive product or system design, hardware design, RF, analog, and mixed signal design, and reliability and compliance issues in design. These are some of the gap areas where if some engineers can focus and build specialization or good competence, I think you will be handpicked by any MNCs or you'll be able to develop a really rugged, reliable, everlasting kind of product system solutions. And then for software enthusiasts, people who are very bullish on AI, ML, and all that, I think AI, ML, and all that is not simply using TensorFlows and using some kind of a tool from the web and trying to run something and training it and being happy about it. It's all about how good you are in linear algebra, probability and statistics, multivariate calculus. You need to be really top up in these subjects design and analysis algorithm, random processes, which is also called advanced probability, and also a good grip on discrete math and graph theory also will be very helpful. So don't think you can do a AI and ML by simply downloading some soft code from GitHub or Stack Overflow. That kind of AI ML, you will be just making yourself a fool. You will be living in a fool paradise. If you really want to do a good solution, you need to really build competence on the basics of whichever domain you are in. Okay, now how do we bootstrap the competence in design? Now, the need to address the vital gap in the fundamentals taught and their applications in product system realization through understanding of design paradigms. To leverage all the theoretical learning and introduce the students to the vast applications of concepts learned through the exposure to an approach to the integration of comprehensive design experience with the engineering curriculum. This is what we are trying to do now in engineering colleges, to teach how do we build the competence to design along with theoretical background. So what are a few learnings needed for system design understanding? As I already mentioned, grasp fundamental concepts in product architecting, like customer needs identification, requirement formulation, functional decomposition, as well as function form mapping during the conceptual design. Understand the platform concepts and be able to prioritize drivers of modularity and product platform design. Enumerate metrics for qualifying commonality within a product family. Synthesize and analyze existing architecting approaches to enhance creativity while reducing ambiguity and complexity. Utilize out-of-the-box holistic system thinking in developing a system's conceptual model and architecture. Define system architecture, modeling, form, function, structure, and behavior. Describe how a system's function emerges from its form and behavior. Distinguish between the notions of a system, product, service, and project, and how each creates value and competitive advantage for an enterprise. Distinguish between incremental innovation and radical innovation when creating new solutions. They are two different things, but both have their own value. Be very clear what you're trying to do. And then understand and apply a 10-step design process. You can Google 10-step design process on the internet. You'll find a very structured, systematic, and very easy to follow process, but this you need to follow. Build a knowledge base of latest technological innovations. Develop new concepts and designs by participating in shared sessions that focus on a limited set of core issues connected to real-world implementations. Understand and practice the crucial design imperatives: safety, security, reliability, standards, compliances, and environmental considerations. Develop a holistic and system-level perspective on smart, sustainable electronic designs. So you got the skill. Now what more do you need? You actually need, beyond the competence, a real passion also, because passion is everything. You give that one emotion to anything and you are bound to excel. Passion helps you enjoy the journey as much as achieving the goal. Passion is actually the lever that helps lift the mundane to extraordinary, the mediocre to excellent. But how do you know what you are passionate about? Ask yourself and you will know. Anything that you love doing or which makes you happy. Those most successful people are those who are able to select careers matching their passion, and that's what I did 4 decades back, and I've really never been more happier. However, in the age of intense competition, everything gets reduced to numbers. Maybe things are easier to understand when they're presented as data that can be compared favorably or unfavorably to something else. So facts and records become far more important than the effort and passion that went into achieving them. So please do not forget your passion. Identify your passion and follow that. And what is the way forward? So as some old saint said long time back, if you want to build ship, don't drum up the men to go to the forest to gather wood, saw it, and nail the planks together. Instead, teach them the desire for the sea. Once they develop a desire for the sea, they will automatically fumble, mumble, and learn how to build a ship. And last thing, but what I'd like you to remember, that design engineers are not paid to make the inevitable happen. They are paid to make happen what otherwise will not happen. So do not think you have done anything what others have been doing, so you are a good design engineer. You need to build that kind of a different kind of a temperament, dedication, competence, that you can make things happen which otherwise without you would not have happened. without your competence, without your knowledge, without your passion. So the key takeaways of this discussion all is need to develop a comprehensive approach to sustainability, security and resilience, and leveraging disruptive technologies and ethically aligned designs, and adopt a systems approach, which I just outlined in the last few slides, to standardization in complex paradigms. Now, in conclusion, we need to develop a sustainable solution for a balanced ecosystem by empowering people to learn and apply nature-inspired strategies in design. We need to develop repositories of resources and launch design challenges where people learn by practicing, providing comprehensive support for bringing solutions to the market, and create a conducive environment and platform for a global network of innovators. In short, together we need to learn about, teach, and practice a radically different way to build our future. So, what is the civilization that we are looking at in future? A nature-aware society that balances societal, economic, and technological advancement with the climate and nature's equilibrium, making our planet carbon neutral by leveraging nature-inspired technology solutions to practice the tenet of circular economy. With this, I'd like to close and ready for questions. And by the way, this slide deck I'll be sharing with the organizers, so you can go through it. It's more of a tutorial kind of a slide deck than a simply keynote talk, because I like to give a complete text to people, because that really helps. You can always study at laser and get an knack of what exactly we were discussing and talking. So Jad, I'm ready for any questions if there are any.
Thank you, Mr. NARANG Kishor. It was a great and wonderful presentation, and very insightful for us as a student and as a engineering students. And thank you also for your great advice for the students. As you said, everything that we have to do it with passion, with and all the power that we have. Thank you very much, and thank you. I thank also the audience for the assistance and for to this webinar. We will move to the questions, as you said, Mr. Narang. If we have some questions here.
Yeah, are there any questions? I'm happy to answer.
Yes, we have questions. We start with this question. Implementing AI in our everyday life bring many bias and discrimination issues. Do you think we are better off?
Yes. It's a very pertinent question. This is what we are always working on. So how do we, make our AI products and solution bias agnostic? But to be honest, bias is always there. It's in the human nature. Whether it's a positive bias or a negative bias, we as a human are, designed the way our DNA is. We develop biases towards different things. So yes, bias would be there. Yes, it would be better if we can, but then all the same. So the real interesting part is technologies are just an enabler of achieving whatever we want to achieve. We need to be very clear. What do we want out of our product, system, solution, so that we can make sure that bias is taken care of. So that's where we have a paradigm called explainable AI. Okay, any AI product, system, solution which can be properly explained why it is doing what it is doing, okay, and how it is doing, how it is achieving, the whole, the genesis of what the synthesis of how it has been achieved this. That is the correct way to do that. So that is where, so ethics are very important. Bias is very important. That's why, so AI is a double-edged sword. Like even nuclear energy, you can leverage it for the benefit of the mankind, humanity, or you can destroy the mankind, humanity. Same is with AI. AI is a virtual tool instead of those nuclear. That's why we say today you don't need all those nuclear bombs or anything. These, our software tools are good enough to, kill an individual, a group of people, a whole nation. So I guess this is a double-edged sword. We need to be carefully, but all the same, we don't need to get scared of also. I'll not say, see, technology are here, so we need to be judicious. Okay, and that's why all these questions of privacy and all these are now coming up. That so we need to be, we do not need to click that I accept whenever there's a winner. We download a new app. We are asked to accept the terms and conditions. We need to be very choosy about that. We need to be more cognizant of our rights and our obligations and our limitations. So that what it actually boils down to is we ourselves need to get educated how to leverage AI as a design guy and as a user. Suppose we are using a solution, then we should know what kind of damages it can have, so that we are aware of the negative impact, so that we can prevent those before we adopt any product, system, solution holistically, wholeheartedly, without looking at it. Does that satisfy?
Thank you. I think it's very clear the answer. We move to another question. It's from Amina. What are the challenges to the widespread use of IoT and AI?
Yeah, so widespread challenges are basically superficial leveraging of technology is something which is more of a nuisance than a real value to the society. Well, that is one thing. But as I said, technologies are an enabler. So it's the application that you develop or someone develops. What impact will it have social? That's why I said, when you're designing, you need to understand the socio-ethical, all those kind of aspects also, moral obligation also. So those are the things that are creating a problem. But that is, incidentally, if you really ask me, you can see the history of technology. Every technology has got some implication of this kind, positive as well as negative. We need to learn how to handle these or tame the tiger, as I said. So don't ride the tiger without a proper, safety gear or way to get off the tiger. Okay, that is you need to have a cautious approach, judicious approach in leveraging any new technology that we are talking about. Yeah. Next.
Yes. Thanks. We have a question from Zuhair. 20 years ago, scientists expected AI in the 2020 years to be far more superior than what we have now. What do you think is the reason for this slow progress?
So I think I very, very clearly mentioned what is a disruptive technology. There's no disruptive technology is a technology alone. It's a culmination of multiple technologies and unfolding of them at different maturity. Each technology is evolving at a different maturity level, at a different speed, pace, and all that. So to put a particular paradigm beyond a threshold, you need impetus of those 3, 4, 5 dependent technologies or paradigms. So once you get that critical mass from all of them, then only you move. So there has been a delay in evolution of these technologies, and even today, what has happened when these technologies evolved? See, our education system, when we went into software development, all that, IT and all that, we forgot our mathematics. Initially, if you remember, in computer science, the mathematics was the core subject. Now we do not focus on mathematics. If you want to do artificial intelligence, you need to be very, very strong in mathematics. Data science is all about mathematics, advanced mathematics, which I showed all the subjects. If you do not have those kind of subjects, how will you actually, develop a good solution? Simply by your coding or training the machine, all these. If you really ask me, machine learning again has different nuances. Reinforced learning. Okay, what is this reinforced learning? Deep learning. How does it really work? It's all hit and try. It's a hit and try. It's not a proper algorithm which works. Okay, unless you develop proper algorithms, and through that you achieve this thing, and you have already validated, verified that this algorithm is valid to solve this problem. So where is that kind of temperament? People are in a hurry to develop AI product system solutions. So in a hurry, when you do something, it really doesn't work in the field. It fails. That's why maturity does not come in the ecosystem. And maturity comes now that people have started understanding that they need to go back to the fundamentals of mathematics and data science and all that, maybe next 5 years. So there's always a learning curve. So there's a hype, then there's a learning curve. Okay, so I don't know whether you've seen the Gartner hype curve. It goes right on the peak, and then there's a plateau of this thing. There's a follow, you can say there's a disillusionment, and then gradually the technology matures. I hope I have answered your question, but I'll be happy to engage with you one-to-one. Yeah.
Thank you for the answer. We have another question from Amina. What are the challenges?
No, I think we have already answered.
I think this question.
Yeah, we have answered
yes,
this. We have answered this. Yeah.
We have a question from Qatar. How do you think the 5G and 6G will revolutionize the industry of IoT and AI?
Yeah, a very interesting question. So I think the two have very different roles, by the way. IoT will leverage 5G and 6G. Okay, but AI will enable and empower 5G and 6G. So AI is being leveraged for 5G to deliver what the stakeholder expect out of it. What are kind of performance, network slicing, all on the fly, you can say network configuration, network everything, all those things. They are empowered, network management, autonomy in this thing, automated configuring. So in very near future we are looking at autonomous networks, absolutely autonomous networks. So they will only be possible leveraging a comprehensive amount of artificial intelligence. Without that, we'll never have fully autonomous networks. So AI will empower these things, and IoT will leverage these 5G and 6G paradigm. I hope that answers the question.
Thank you. We have another question from Amir. Does privacy exist in IoT?
Well,
question of,
the question is very not clear. Does it exist? Yes, it is important, but it depends on the solution. It exists. It depends on the way you have designed the thing. People are demanding privacy to be respected, but so it's the way you design a product and how you use a product, deploy a product, that privacy concerns can be addressed. Otherwise, it's a double-edged sword, as I mentioned.
Thank you. We have another question. With all the technologies that you mentioned, aren't you afraid of the effects of over-engineering our way of life?
Oh, well, that has always been a way of this thing. That is something which we have been always, facing this thing. So the real interesting part is how do you leverage technologies? I'm not afraid. So you know why? In 81, when I left my last job, or even 77, I did not become an entrepreneur. Why? Because I always wanted to, work on newer technology. I wanted to stay a few steps ahead of the market. I'm not afraid. Why I'm not afraid? Because I know how to tame the technology and how to use appropriately technology. So about AI also, when I mentioned that it is likely to become a new plastic of the world. Okay, because of the adverse sustainability impact of AI. So you need to have that vision, and then accordingly make your strategy how to leverage different technologies. And you don't need to get into everything. Like blockchain, I'll say. Blockchain also got a lot of hype. Everybody says that. So blockchain has, again, a lot of compute power, unnecessary compute power, all that. Every use case, you do not need automation. Every use case, you do not need AI. Every use case, you do not need blockchain. They are specific. So appropriate leveraging any particular technology will keep you and your product, system, solution, and your life in reasonable semblance. But yes, if you start over depending on them, yes, your life will be chaos, and then you better be scared. You are absolutely right. I think this question is very, very interesting. And are you not scared? Absolutely. You should be scared. So I think being scared is in a way good also. You become cautious. Okay. So I think in a way, healthy way, I am scared. That's why I'm cautious. So I try to first understand the whole thing and then handle it accordingly. So a little bit of scary is good, but not too much.
Thank you. We have another question.
Yeah.
what role can IoT play in crisis? For example, if we talk about what's happening in now with COVID-19.
Oh, I think you must, download the articles of, there's a IoT magazine of IEEE. Okay. There's a COVID-19 special issue. So there are multiple use cases where IoT has helped in the COVID-19 this thing. Okay, you can go to the IoT. So there are multiple. I mentioned means I can actually send you the links and the thing where you can talk about a use case and you see what people are even trying to do. Network all the medical devices. So everybody does not want to be hospitalized because they are scared of so many problems. They'll get infected. So when the hospital started, and because hospitals are short of beds, ICU beds, and all that, so people are preferring home care, home quarantine. And when there is a home quarantine, their essential parameters need to be monitored. Okay, and by the doctors. Doctors are sitting in the hospital or in their own homes, and so the patients are being provided the smart, you can say, pulse oximeters, all the other instruments, medical devices, which are being remotely monitored, and then accordingly a proper, you can say, prescription of the treatment is being given time to time or changed time to time as per need. That is one of the very interesting use case and very relevant. That staying home and you are still being cared, you don't need to get hospitalized every time, because of this is only possible because of IoT. So we have apps where within 5 meters, if you of your the thing, if there's someone who is infected, you'll get to know. So people, the governments are doing a lot of, innovators are doing a whole lot of things. It's basically up to your imagination. You can develop a solution for using IoT for any use case. Whether this, like disaster, this thing, IoT comes very handy whenever there's a disaster, any kind of natural disaster or man-made disaster. IoT is really useful, but then there has to be communication backbone. There have to be devices somewhere.
Thank you, Mr. Narang. We have another questions from Slima. Does IoT have limits?
Well, yes and no. I think they're very. See, as I told you, technology is there. It's up to your imagination. What kind of product, system, solution, or what kind of you want to design, and what kind of problem you want to solve. Okay. Now, so every technology brings you something on the table, but also does not bring everything on the table. So there may be certain use cases which may not be possible to solve it with IoT alone. You may need something much beyond that, much more comprehensive system. Okay. So IoT, so the interesting part is, what do you understand by IoT? IoT, you must understand, it's just an overlay on the ICT infrastructure. You need an ICT infrastructure in the city, in the country, in the state to leverage IoT. Okay, communication infrastructure has to be, the IT infrastructure has to be there, so that sitting in your office, you can remotely open the lock of your home door, or switch on, see through a video camera who is knocking your door, ringing the bell. You can open the door, switch on the light, switch on the coffee machine, ask him to have it by the time you reach. Okay, or before reaching your home, halfway through your home, your room is hot, so you switch on the AC. By the time you reach your room is cool. So there are limits, there are no limits. It's totally up to your imagination and the use case. But whenever there's an extra control, but again, like you say, remote surgery, where you need a very precision. As of today, there's a limit. But with 5G and 6G, that limit also would be broken. Does it answer your question?
I think everything has a limits and no limit.
Yeah, absolutely. Yeah.
We move to another question with Ibrahim. What the efficient programming languages used in artificial intelligence?
I'm not a software person, to be honest, so I'll reserve my comments on that. I'm more of I'm a hardware person and system design guy.
We can propose Python. Python is very
no. So Python is more of a language for people like me who do not know programming. Okay. If you really ask me. So see, Python is okay, but then leveraging Python, simply downloading something from GitHub and Stack Overflow and using it will not give you a good AI system. Let me tell you, all this open source, you need to be very, very careful about it. Okay, if you really want to do a professional industrial grade, rugged, reliable product, hardware or software, you cannot depend on open source things which are available on the internet, hardware or software. In Raspberry Pi, Arduino, they are good for learning. They were getting, but they are not the thing which you download, integrate, and give you a solution. And that's what today's startups are doing, which is really a very, very suicidal tendency. They are going to kill themselves in the next 1 or 2 years when the product starts failing in the field. So, if you really ask me, if you really want a most optimized product and a rugged, reliable product, then you go back to your C, C++ are still the root. Then Java. Okay, they are still the basics of any kind of thing. C is the most efficient programming language where you can have, full control on the hardware, each and every register and all that. In fact, below that, there used to be assembly. I don't know whether you guys know. Assembly used to have control each and every machine cycle of a processor or a controller. Okay, but today we are going more and more abstract level. You get everything done, plug and play and run. Like TensorFlow, you don't need to do anything. You got all those platforms available. That makes your life easy to do some kind of a learning and all that. But when you want to do a professional grade product, which you want to sell or deploy somewhere in the field, I'm sorry, this plug and play, copy paste will not work for you. You need to be a good hands-on ground level coder and programmer, but all the same, your real strength in AI is algorithms. If you can develop right algorithm, write algorithm, coding anybody will do for you. Whether you do it in Pascal, whether you do it in C, whether you do it in your Python, whether you do it in Java, or any new or old language does not really matter if you really ask me. The real grip is, do you know how to design your algorithm? And make sure that your algorithm works granularly. You have full control on your algorithm. If you have that, you can develop that, you can relax. You can use any language or whatever comes easy or whatever kind of, products are there.
Thank you. I think you are right. As we in ICT College of Engineering in Morocco, the first things that we see are the programming language with C, with the assembly, assembler, and the other program and the algorithmic way to think. It's all about algorithm and how we can use them in the after.
Sure. Mm-hmm.
We have another question from Qatar.
Yeah.
As an engineering student, how can I keep myself updated with the new technologies while the digital transformation nowadays is very fast?
Okay, so as I already mentioned, it is really, there's so many things evolving. So I think you will need to identify your priority areas. So you can have a bifocal thing. Keep a short-term thing where you need to specialize for day-to-day job and immediate goals and all that. Then have a watch on the long-term horizon. You just don't need to study everything in depth. Keep an understanding, get a basic understanding what these new technologies are all about. Gradually, as you move in your career, those technologies start becoming mature. And if you get an opportunity or you get interest or project to work in that domain, then take a deep dive in that. You don't need to deep dive into everything. Okay, deep dive into your current or immediate next few years related technologies, but keep a basic understanding of all the long-term technology which I just mentioned, and keep an eye. Today you have internet at Google Baba for your thing. It can really help you a lot. In our times, we didn't have Google Baba. We did not have internet. So even at that time, we could still do that. If you have passion, keep an eye on how things are evolving. Rest your basic intelligence will come handy to you in surviving this thing, and don't try to be master of all, be master of one, jack of all, yes, understanding of all. Even I also, if you really ask me, I'm not an AI hands-on person. I'm not a machine learning hands-on person. I'm not a software coder even for that matter. I'm a system design person and hardware. These are two of my strengths. Hardware as a design engineer and system architect. Now in last 20, 40 years, I've learned how to develop most complex system solution and all that. But beyond that, when I also today design a system or a solution for deep down, I also need domain experts who will work on the software and the particular nuance of hardware. RF, you ask me to design an RF module, RF PCB layout, I cannot do it myself even today. And there's no shame in that. Nothing to worry about that. Don't try to excel in everything. You will never be able to do it. So have a good understanding of the layout, what is happening around, what are the interdependencies, interplay between different technologies, and identify your focus areas based on your passion, based on competence, based on your liking, or based on opportunities. I think that should take you well ahead in this thing. I have survived last 40 years. So, I am from the age in my engineering, we were taught vacuum tubes. And today I'm working on all heterogeneous SoCs using FPGAs, ARM processors, and GPUs and all that. I'm developing solutions for defense, for space department of my country. I'm perfectly comfortable. And system level design, I can do it.
Thank you, Mr. Narang. I don't know if we have another time to manage other questions because we have
no problem. I have another 10 minutes at 9 o'clock. I have another meeting, but before that, I have another 10 minutes in case you need. Yeah.
Yes. Thank you very much. We have another question from Asma. Do you think does every aspiring IT engineer should master both AI and IoT?
No. IT is different. IoT is different. AI is different. Do not mix them up. They're entirely three different things. IT is about services, computer service software, basic application softwares and all that. Okay, for all the applications and all that. It's not even about mobile apps. It's all about general softwares and administrating the enabling everything with IT. That is a very, very superficial layer. Okay, for which you do not even need to be an engineer. But AI is a computer sciences subject with a lot of mathematics. IoT is more of an electronics engineer subject with a hardware, as I mentioned, basic background in hardware and product design, and then learning embedded software, learning communication. The software part, somebody else can do the, at the cloud level and the app level, but then as a team you can do. So you need to pick what you like to do that based on your background. As an IT, you can do, if you really ask me, if you already have an IT background, what you could still try to salvage is as IoT solution, integration and all that kind of work. But designing all these things, you cannot. You need to have that kind of a basic theoretical background, which you can now convert into practical training, practice and all that. That is my percent. I may be wrong, but there's nothing. I'll tell you one thing. Don't try to, go with the hype. Please, hype will keep on coming in different ways. Will keep on coming and going every few years. I'll tell you one thing. As a design person, a lot of clients come to me they ask me, sir, can you give us design something? We'll pay you whatever you want. Design something which has good scope. It's a very interesting question. And so what I tell them is, look, I may design anything for you. The point is, if you are not able to handle it properly, then even if I give you the best design, most cutting edge technology based in unique product, you will not be able to grow. But if you do business in a proper way, okay, even if you pick up a product, a consumer durable product, which everybody else in the world is making, you will still be able to get an automatic market share. So what I suggest to the engineers is pick up whatever subject you like, you are good at, excel in that. You will make a good success in your career. Do not try to go with the wave. Excel in whatever you pick up one subject, master that. Become a super specialist in that. You will be valued by the different organization or whoever it may be, your clients or MNC organization, whoever. Okay, build some specialization one. That will take you far off, rather than dabbling from moving. Today we have AI IoT, tomorrow you will be AR VR, tomorrow then you'll say something else. How many times you keep on switching gears? You'll go mad. Is it really worth it? Life is more important. You are first a person, then an engineer. Remember. Yeah, go ahead.
Yes, thank you. It's very clear. We have another questions, if we have time to add.
Sure.
From Fad Alawi, can we implement a heavy machine learning algorithm in microcontroller? If so, which library would have?
No, heavy ML. So today we have some controller, but then no, heavy ML you will not be able to do it in a microcontroller. There are microcontrollers today at a ARM Core M7. Okay, within that, right up to they have up to 600 megahertz, 400 megahertz, 480 megahertz. M7 is already there. Okay, so the M7 core, there you can do something with, but then you need a more memory also and all that. But it's actually combination of multiple things. Now there are new AI friendly cores also coming up. Okay, where you can have the so in fact for microcontroller embedded application, some processor or SoCs are coming with AI engine already built in. So try to identify those rather than using a general purpose microcontroller and then deploying, putting your heavy ML algorithm and doing your own code and all that. So if you really ask me, I cannot help you with which library because I'm not a AI ML person. I'm not a software person, as I already clearly, honestly told you. But the real challenge is identifying the right devices, platforms. If you share with me the problem, I'll be able to help you identify what would be the right kind of a microcontroller or processor platform. That much I can do.
Thank you. We have another question. Will 5G have a big impact on IoT, Internet of Things?
Yes, it will. It will help make certain use cases, which I showed in my slides also, which were not possible till now. It will make them possible. Yes. So that way it will have the impact. No negative effect, only positive.
Thank you, Mr. Narang. We have another question.
Okay.
What are the limitations of MicroPython?
I don't know. That's not my domain. I'm sorry.
Also, sorry. I don't.
No, I'm not a software person. Basically, I know a little bit about this thing, but I'm not the right person to answer this question. Sorry.
Thank you. I think we finished all the questions that we have.
Okay, good.
Here. So, thank you very much, Mr. Narang Kishor, for your time and for that you give us to give this very wonderful keynotes.
No, I enjoy interacting with youngsters because if we do not guide them, they will always be confused what to do or where not to do. So I think this is one of my core commitment to my payback to the society. That I like to interact with the young people, and you can share my coordinates with them. They can connect with me. I'll be happy to answer anybody's question through mail or however. I'll be more than happy. Always available for youngsters who are trying to do something genuine.
Okay, thank you very much.
Thank you very much, and not the least, I also enjoy it. Thank you.
Thank you very much. We also enjoyed very much.
Namaste from India. Yeah, namaste from India. Yeah.
Thank you.
Bye.
Goodbye.
Bye-bye.